Good evening, everyone. Welcome to CAD Technologies. Today, in this session, we'll be learning how to make a crankshaft. This is not a complete drawing of a crankshaft, this is just a small example. A crankshaft drawing has more precise details. Now, understanding the drawing is the first thing which we are supposed to do before getting into what we are working on. So, firstly, understanding the drawing, there is a front view, a right view, a left view, a top view, and a detailed view. The front view is basically a cross section which is cut at this location. As you can see, I'm moving the mouse, and the section view is shown in the front view. This is the right view for better understanding of the shape of the crankshaft, as well as the left view for the internal features like holes, etc. Now, there is a small groove which is given as a detail A, which is a 4 by 2. Now, we'll be using a simple part module to make this, but the shape, as you can see here, this kind of shapes cannot be achieved using your part module. So here we'll be using a little bit of surfacing, and we'll see how we can remove a certain material of a solid from a surface. Now, let's begin. As you all know, we are supposed to enter using mechanical design and part design. Now, under part design, before beginning, you can see that the body is a cylindrical body. You can see the 100 dia, you can see the 80 dia, you can see the 30, 40 dia. That means the whole body is a cylindrical body. So, to make a cylindrical body first, we can use a shaft command. We can of course use pad, but there are certain features which we are supposed to maintain, like the 250 symmetry and the overall 100. So let's try to use a shaft command to do so. Again, taking my sketch beginning and selecting my axis. Now let us design the rectangle and give the dimensions as per our requirement. The whole diameter is supposed to be 100. It's actually shown over here. Now let's try to maintain symmetry before giving the overall dimension, because it's overall 250 and it's equally distributed with respect to the center. Now this is the actual sketch. When I exit, it will create a complete cylinder, as you can see. Now, following the feature based approach, let's start removing the material one after the other. To remove the material, again we'll be using the groove command. We cannot use any other command over here apart from groove. So let's try to make a sketch inside the groove and start taking a references wherever necessary. The axis, of course, and the ends of the cylinder, of course. Here we require the corner as well, not mandatory, but for me it's easier that way. I'd like to make a sketch to remove this portion of the cylinder. So let me try to use profile so I can make a single sketch and then close the sketch in one go, as you can see. Now start dimensioning them. Again, double click on the dimension command. You can use it more than once. The outer one is actually 30, so let's try to maintain 30. As you can see, it's still activated. Double click on it quickly will help you do that instead of constantly going and clicking on it and doing it every time. Now we know this length again, which is given as 40. We know this length which is given as 50. It's over here 50 and 40. Now exit will create the cut, as you can see. Similarly, there are a few cuts here as well. So let's try to go one after the other. I'm trying to make this cut next. This also has to be done using a groove command. Selecting this as my center sketch. This is the axis and I need the projection of the entire body. Now, to begin making the sketch, let us see what portion I want to cut and make the sketch of that portion first. I know the dimensions, that is from end it is supposed to be 20 and this is supposed to be 30. The diameter of this again is given as 30 TYP, that is 30 throughout wherever you have that feature. So let's try to take that and give this as 30. This is completely constrained. Now when I exit, it tries to remove the material. Now, the second cut, the groove cut, has the material over here, not as the center. So let's see how to do that. Let us go back to your sketch and now let us go back to our drawing. Now, in the drawing, they have specifically mentioned that the axis is at 30. So when you're taking it, you can take the axis and give it at a distance of 30. This is supposed to be 30. Now this is your axis and you will be using this to create the material which you're supposed to remove, of course. Now I cannot remove the material here because there will be some material left on the other side. So I'm trying to remove it this manner. Dimensions are again given here. From here to here is again 20. You can also give typical while creating the drawing. Just for understanding, I have given it this way. And the diameter, since they have given it as typical, this is supposed to be 30. Exit. Now you can see how it tries to remove the material. Once I say OK, it tries to cut it. This is because the axis is located over here. Now there's also another cut, 40 by 40. So again, let's try to use the same groove command. This is a very easy cut which we have already done before. But again, let me try to take the references as well as the axes. And I want this reference as well. Now, let me go back to making my profile of which I want to remove and then start dimensioning it. This is supposed to be 40, which I've already mentioned a minute ago. This also is supposed to be 40. Exit, it tries to remove the material. This is the feature-based approach to make a simple crankshaft. Now, achieving the shape is the second part. Achieving the shape, you can see the shape. We can cut this shape off of the existing body on the diameter 100. Let's try to begin with this. You can either directly make a pocket or make a sketch first. I prefer making a sketch first. And I want to use the corner as my reference. And I'll just take it to the 3D view. I want to use this body as my reference because the center of this arc is in line with this. As you can see, there's the arc here. This is in line with the 30. So I'm using that as my reference. Go back to your normal one. Now start making your profile. As you can see on the screen, the profile is a combination of arcs, which is this arc, a straight line, and a 35 arc and a straight line. So I want the arc which is supposed to start from here, continue till there. Now I have a straight line which is located over here. It's actually at a distance of 80. So from the center it is supposed to be at a distance of 40. You can also give a diametrical dimension if you're interested. You can create a mirror and then keep that as a reference as well. Now I have a 35 arc. So from here I'd like to take 35 somewhere over there. But we know that the point is on the outside because it's at a distance of 20 from the center. So I'll just give that 2. And give the dimension of the arc to be 35. Now it has to join with a straight line. Let's try to take a line from this corner to this corner and then try to maintain tangencies and then maintain vertical. Again, maintain tangencies and then make this vertical. Let's try to maintain tangency. This got over constrained because of some, yes. Now we have to remove this portion from the center. We have to cut off this area of the existing cylinder. Once I say exit, you can see the sketch. You can use pocket to cut it up to the next surface. It's not cut through because you can see that this shape is rotated to 90 degrees on the back side. So you cannot cut it through. Now the same feature again can be mirrored onto the other side and then left it. You can see the groove now. I can just show you by rotating, you can see the groove. Similarly, on this, the actual rotation of the body is rotated to 180 degrees. So when I'm making a sketch over here, I require this shape to be on this side. So while making this, I know it's a little more. We require a little more dimension and better control on the body while doing it on this side. So we can just directly give the dimensions and then start working on it, presumably this way. Now we know that this is at a distance of 30, which we have already seen. which I've already shown you over here. Now, there is a straight line over here. I'm doing it the other way around as you have seen earlier. It's just the 180-degree rotation. You can save the sketch and also do it, copy paste it as well. There's no problem. Now, I have an arc which goes this way, which again you already know, which we have already seen. That's again at 20 from the center. So let's try to take it at 20 from the center. And the arc diameter is 35. I'm trying to make a line. I'll be extremely careful while doing so because I don't want to give any additional constraints like last time. One tangency. This is my second tangency, and this has to be. Now again, try to make the same arc, or you can actually project the arc which is already existing there. Instead of trimming, I'm just trying to redo it again. Exit. I'm trying to cut this off of the existing body. Again up to next. Again you can mirror it onto the other side. This is your cut. The same cut has to be done on this side as well. So instead of redoing the whole sketch again, what I will do is I will just try to project the whole body onto this sketch. Projection is very simple. This is the arc, this is the line, again the arc, again the line, and again the outer sketch. I can trim off whatever I don't want and I can keep whatever I want. So while doing so, I have to be very careful. And then I don't need this area. So let's just try to trim this whole area off. And I don't need this small portion as well. So let's try to trim that off. Once I exit, you will see the sketch. Again, you can create a pocket of it and then mirror the same thing onto the other side. I have just used this sketch onto this body. It's an easier way of doing it rather than doing it over and over again. Now, continuing with the model, as you can see, there's a 80 typical cut at this on this feature as well as on this feature, as you can see. But on this, the cut is only on one side, that is on this side, which is at 35. When it is on one side, you cannot use a simple groove command. It is necessary to achieve this shape. It cannot be achieved using groove. It requires making some curves as well as performing a surface and solid cut operations. First, we'll try to make this cut and then see how to make this one. So let's try to make a groove of it using this is using the axis, which we already know what is the axis, and we require the projections of the faces. Sorry, not the axis. I require the projection of this edge. Okay, I'll just take the projection of this body instead. I can get the center point that way. And then while making my sketch, I know that the sketch should start from here, which is my center point, and then look at it. This is the logo of this is the icon for midpoint, as you can see. Now I want this line to be on this line. I think it's already coincident, so I don't have to do much. I only have to give the 80 dia. Now let me try to give the dimension for the end point with respect to the axis. From the end point with respect to the axis, this is supposed to be 40. I'm just selecting a point, that's why it's not doing it, and the axis is the exact center. That's probably why it didn't take this as the axis, did not understand that as the axis. This is my cut. Similar cut can be performed on the back side of your body as well. Now I'll try to take this as an axis instead of a reference, and then I'll use this as the reference. Now I can show it to you in a better manner. I'm trying to make a sketch this way. Now again point, axis, right click, you'll get radius diameter. This is supposed to be 80. I just did it to show it because I can again use the same reference if I want to, but better to get it that way. This is another groove. Now to do it to this, you cannot use a groove command because to achieve this shape as I'm trying to show you, you cannot use this, but you can use your curves. So first let me try to take a midpoint, as this is exactly located at the center. I'll just try to use my references to locate the center and create a center point over here. This is the first reference. And the second reference, which is pointed out in the drawing, is at a distance of 35 from the center. So on this, let me try to take another point exactly at the center with the dimension of 35 from the actual center of the crankshaft. Using these 2 points, I would require to create a curve. To create a curve, I need to go back into my wireframe surface design and use a simple spline command. You have the corners. It tries to create a spline easily. Again, I'm using another one. I'm trying to create a spline here. This is the shape as you can see over here. This cannot be achieved using a group command. You can give it a go. Now you can directly create a fill in between these two curves, and then see the surface. Now the problem is, to create a solid and a surface cut, it is mandatory that the surface should intersect with the solid. So to provide the intersection, I am just giving an extrapolation, which is an extension to the existing surface. I'll unhide the existing body. And to remove this, we can go back into your part design and start using your split command. Split is a very easy command to use. You just have to select what is your splitting element. When you say OK, it tries to split it. You can hide the surface and I will show you how the shape looks like. This is the shape. You can hide the curves as well if you want, and the points. I'll just try to hide the curves as well as the points, and you can see them. I was just trying not to delete them, and I want to be very careful while I do so. So this is how you do it. This is using your split command. Now, final are your slot as well as your holes. So first, let's try to give the slot. We all know how to give a slot. You can use the command. Now, while giving a slot, let's try to maintain the correct right view and then fit into the screen. And this is actually my reference. Yes, that is my reference. Okay. Now on this reference, I'd like to make the sketch of what I've seen, which is a simple U shape because I need the arc in the end anyway, so I'm just giving a U shape. I know this is supposed to be 4 by 2, so let's try to give 4 by 2 and maintain symmetry. You right click, allow symmetrical line. Now try to maintain the 4 and 2. This is 4. I'm sorry. Yes. And this is 2. Now we require to create an arc over here, so let's try to do that as well. This is my center. Sorry, I got this place. And the start as well as the end. This cut is not up to next. Of course, there is a certain distance it is cut to, which is 25. So I'll just give a dimension to say it's supposed to be cut only up to 25. Now there are two different holes drilled, which is 8 diam to 40 depth. I'm just selecting this. Now first it has a V cut, as you can see. So I'll just try to take a V bottom over here and give it a V bottom, and now try to make the sketch. The sketch, of course, it should maintain concentricity because again, when you update, the whole body should update itself. The diameter is 8 and the depth is actually supposed to be 40 as shown in the drawing. Similarly, there's a hole on the other side. On this side, I'll be simply using the hole command again. I'll give the dia first, this time 20, and the depth is 30. It also has a V cut, as you can see. Now again, I'm trying to make a sketch and then maintain concentricity. It's mandatory to maintain concentricity or 0,0 location. It's up to you. If you maintain concentricity, it gives a better control on the body. This is how you make a very simple crankshaft using shaft, groove, your pockets as well as your holes, and the main command is your split, wherein you cut a surface off of a solid. There's a major crankshaft drawing with a lot of details. If you want to learn more professional level of that type of training, you can contact us. Our description is given, our details are given in the description below. I'm so sorry. You can go through it and you can either WhatsApp or call us regarding the same. Thank you.